All right, so we are going to be doing roughly 3 days. I gave us this week, but the goal is 3 days of completing all of 8. But realistically, I gave us this week. So starting here, we're going to talk about reviewing analyzing the graphs. So from last week, we talked about how do you analyze the graphs of rational functions. The first thing you want to do is factor your numerator and denominator into their lowest terms. Okay, you want to find your domain. Your domain comes from your vertical asymptotes and your holes. Asymptotes and holes. Okay, you want to determine your intercepts. If any, the x-intercept is any number in the domain where n of x equals 0, and the y-intercept is r of 0. So basically, for your domain, for your x-intercept, you're going to let your numerator, you're going to set your numerator equal to 0. And for your y-intercept, that means you're setting your x equal to 0, right? And simplifying. Okay, you want to find any real zeros of the denominator to determine your vertical asymptotes. You're going to locate any horizontal or oblique asymptotes. So remember, that's where we talked about you're paying attention to the degrees of your numerators and the degree of your denominator, not numerators, degree of your numerator and degree of your denominator. And that's going to tell you what you have to do. So if the degree of your numerator is less than the degree of your denominator, remember that's a horizontal asymptote at y equals 0. If the degree of your numerator equals the degree of your denominator, that's a horizontal asymptote at y equals your leading coefficient of your numerator divided by the leading coefficient of your denominator. And if n is greater than, if the degree of your numerator is greater than the degree of your denominator by only one, then that makes you have an oblique asymptote. And that means you have to do long division or synthetic. Okay, for any symmetry, by replacing x by negative x, you can determine whether it's odd or even symmetry. And then you're going to determine where the graph crosses the x-axis by using your zeros, your intercepts. And then you graph it and put it all together. Okay, so that's the gist of everything we talked about last week. That's all of last week in the summary. Any questions about last week? Leading coefficient. So the leading coefficient of the numerator and the leading coefficient of the denominator. Yes. You didn't get that out. Okay, so again, this is summarizing 7. Section 7. Is there any part of section 7 that you're like, nope. Okay. So here we go. We're going to go through, and all 8 is just a build on of 7. Talk about the rational functions even more. But it's supposed to be more of you practicing and you analyzing and less of me, whereas 7 was me guiding you through the whole thing. Okay. So here we have the rational function x squared plus 7x plus 12 divided by x squared plus x minus 6. Okay. So following what the step said, we should do what first?
Break it down, right?
Break it down. We want to fully factor everything.
So we will get x plus 4 and x plus 3.
Perfect.
Oh my God, I'm finally ready.
And FYI, he's the one student that wasn't in my class last year. So it's possible to catch up. Well, you took your regular, you were at honors on another campus. Okay, here we go. X squared plus x minus 6. What does that break down to? -2 and +3. Okay. Questions about step 1? Okay, now we're going to find our domain of our function. Okay, in order to find our domain of our function, we're looking at our denominator. Our denominator tells us our domain. It'll be your denominator is.
Oh.
So we have a whole.
Yes, we have a whole, but still it's a discontinuity in our domain, right? So I take each factor and set it equal to 0, and that's gonna tell me where's my discontinuity. It's not asking what it is, it's asking where it is, right? Your domain is saying where is all this happening on your x's. So we have x equals 2, x equals -3. We may or may not know which is a whole and which is an asymptote, but we do know that these are problems in our function, right? Okay, so my domain is from -infinity to -3, -3 to 2, 2 to infinity. And why is that? Because x cannot equal 2 and x cannot equal -3.
Oh, so when is being continued?
Okay. Step 2, are we good? Step 3 is where we're gonna actually we're gonna find our intercepts. We're gonna find our intercepts of our graph. So to start off with this one, our y-intercept is gonna be the easiest thing to find. Your y-intercept means you're gonna let x equal 0. So if I let x equal, and sometimes it's best to go back to the original. If I let x equal 0 in the original, what's gonna happen to these two terms? They cancel out. What happens to these two terms? Cancel out. So all I'm left with is 12 over -6, which equals -2. So my y-intercept is at 0, -2.
Wait, can you say that again?
Yes. So to find your y-intercept, a lot of times it's easier to go back to the original. And if I plug in 0 everywhere there's a variable, all I'm left with is 12 and -6, correct?
So what does 7 and
Huh?
7x and multiplied by 0? Oh. Okay.
Yeah, yeah, we are. When we talk about the y-intercept.
And what's up with 0?
But it's easier to
Thanks.
find the x-intercept
All the
because
variables.
it's just what's left in the numerator.
Everyone-
Well, yeah, but also I'm just saying visually, it's easier to find your y-intercept. Just all you're doing is looking at your constants, right?
So we-
So if I'm looking for my y-intercept, I'm just going back and looking at the constant in the numerator, the constant in the denominator.
0 squared, 0 squared, 7 minus 0, 0, and then you get 12.
Yeah. So your y-intercept is just gonna be the constants of your numerator over the constants in your denominator. Does that make sense? Okay, all right, x-intercept. Exactly. So when you do your x-intercept, notice that at this point, I'm gonna eliminate, right? So when I simplified this is gone. So I'm left with x plus 4 over x minus 2. Okay, to find your x-intercept, you are setting the simplified numerator equal to 0. And my simplified numerator is? Yes. So all we're doing is taking x plus 4 and setting it equal to 0. And what do we get? X equals? So my x-intercept is at -4, comma 0.
We don't do anything with the negative with them, or with the numerator, right?
Your numerator is how you find your x-intercept. We don't do anything with the 2, that's the denominator. Yeah. Your denominator tells you your domain. Okay, now we're gonna analyze, yes,
So it's only the top one that we get.
for your x-intercept. Yep, only the numerator. Perfect. All right, so now we're at 4. So at 4, it's asking us to find our asymptotes, our vertical asymptotes, and or holes. So do we have any vertical asymptotes? Yes, so to find your vertical asymptote is by setting your denominator equal to 0, and what is it at? +2. At x equals 2, there is a vertical asymptote. Okay, our hole was at x plus 3. Why is it a hole? It's eliminated, right? It was both. It was in the numerator and in the denominator. So we have a hole, and our hole is at -3 what? Does anyone know how to find where the hole is at? You plug it in. To find your hole, the exact location, you plug it into the simplified
Oh. You plug the,
-3 in.
okay.
So to find your exact location of your hole, you're gonna plug it into the simplified. So we have -3 plus 4 over -3 minus 2, which gives me 1 over -5. What are these numbers? You keep yelling at me.
Oh, I thought it would.
So my exact hole is located at, there you go. All right, then now you're down to finding your your horizontal asymptote or oblique asymptote. So for this problem, what do we have? We have a horizontal. And which type, do we have y equals 0 or do we have y equals leading coefficients? Leading coefficients.
So that means it's not.
Because your degree of your numerator is equal to the degree of your denominator. So remember, that's your y equals leading coefficient divided by leading coefficient. So the leading coefficient of my numerator is 1. The leading coefficient of my denominator is 1. And 1 divided by 1 is 1. So at y equals 1 is my horizontal asymptote.
But you understand it. How would you get it?
Okay. All right, so let's graph it. Let's graph everything that we have. So we're going to go with our vertical asymptote. We have a vertical asymptote at 2. Yes. We have a horizontal asymptote at y equals 1. We have a hole at -3, -1/5. So somewhere in this little space, right? There's a little hole. Okay. So when it says to determine whether your graph is above and below, all you're doing is plugging in values to the, oh, I didn't plot my intercepts. Where are my intercepts at? I have my y-intercept at 0, -2. And I have my x-intercept at -4, 0. Okay. So because of this, I know that this side of this function is joined. It is the most curvaceous graph you've ever seen. Go with it. It's go with it. And then on this side, you're going to put in a value to estimate where it's at, or just follow the curve. So I'm going to plug in 4. Seems easy. 4 plus 4 is 8. 4 minus 2 is 8 divided by 2 is 4. So I know that 4 has to go through that. So we're doing, and there's my function. Okay, that's all the rest is asking you to do. So 6 through 8, you can kind of just sketch out and figure everything else out. This one? I plugged 4 into the simplified. Yep. All right. Okay, so the purpose is to keep practicing. So on the back are more practice problems where you're going through exactly what we did. And you're just telling me more exactly of what interval am I going to test. So once I have it graphed, where am I positive, where am I negative? And we'll look from there.